Hello students, in last session in chapter number 8 Introduction to Trigonometry in exercise 8.4 up to the 5 question from the question number 5 completed. Now we discuss 6th number from the question number 5. 6th number on page number 194. Square root of 1 plus sin a upon 1 minus sin a is equals to sec a plus tan a. First of all, write the left hand side. LHS is equals to square root of 1 plus sin a upon 1 minus sin a. And we need to prove that in right hand side sec a plus tan a. As we know, sec is reciprocal of cos. 1 upon cos a is sec a and tan a is sin a upon cos a, which is tan a. So that here terms are in form of only sin a. We have to take again cos a. Its above term is 1 plus sin a upon cos a. 1 plus sin a is in numerator. Again, we don't require a square root, so that in a square root 1 plus sin a upon 1 minus sin a multiply with 1 plus sin a and divide with 1 plus sin a is equals to square root of 1 plus sin a comes 2 times, so that 1 plus sin a square upon 1 minus sin a and 1 plus sin a are factors of 1 minus sin square a is equals to square root of 1 plus sin a square upon 1 minus sin square a. We know the identity, which is cos square a. Now square and square root both are cut. Square and square root both are cut, remaining 1 plus sin a upon cos a. Put the cos a in the denominator of 1 and denominator of sin a. 1 upon cos a plus sin a upon cos a. 1 upon cos a is equals to sec a and sin upon cos is equals to tan a is equals to our right hand side. Therefore, LHS is equals to RHS. That's why our left hand side is square root of 1 plus sin a upon 1 minus sin a is equals to sec a plus tan a is proved. Okay, hence here 6th number is completed. Now the 7th number. On the same page 194, see the left hand side. Sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equals to tan theta. Our left hand side is sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta, and we required only tan theta in right hand side. As we know, the tan theta is equals to sin theta upon cos theta. Already the left hand side in form of sin and cos. See the numerator. Take sin common from both the terms. Sin theta upon 1 minus 2 sin square theta upon, now from the denominator cos theta is common, into bracket 2 cos square theta minus 1. Now as we know, sin theta upon cos theta is equals to tan theta. Put it into a bracket whichever we required. Now here 1 minus 2 sin square theta as it is upon into bracket, suppose 2 as it is, convert cos square in form of sin square. As we know, sin square theta plus cos square theta is equals to 1. That's why instead of cos square theta we have to write 1 minus sin square theta. 1 minus sin square theta minus 1. Sin theta upon cos theta is equals to tan theta, which we required. Multiply 1 minus 2 sin square theta upon 2 multiply with bracket, 2 1s are 2 minus 2 sin square theta minus 1 is equals to tan theta into 1 minus 2 sin square theta upon 2 minus 1, which is 1 minus 2 sin square theta. Bracket is over. Now both numerator denominator equal. We get only tan theta. Tan theta is our right hand side is equals to RHS. Therefore left hand side is equals to right hand side. Hence our left hand side is sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equals to tan theta is proved. Okay. Now see the next 8th number on the same page, page 194. See the left hand side first. Sin A plus cos A whole square plus cos A plus sec A whole square is equals to 7 tan plus tan square A plus cot square A. Our left hand side is sin A plus cosec A square plus cos A plus sec A square. We required in left hand side 7 plus tan square A plus cot square A. See, first of all do the expansion in both the square of binomials. Square of first term sin square A plus 2 sin A into cosec A. Sin A into cosec A plus square of second term cosec square A plus cos square A plus 2 cos A into sec A plus sec square A. Now arrange it by identity or relation. First is sin square A with cos square A plus 2 sin A into cosec A plus 2 cos A into sec A, and remaining 2 are cosec square A plus sec square A. Okay. Now identity sin square plus cos square is equals to 1 plus 2 sin A into cosec A reciprocal of each other is 1 plus 2 cos A into sec A reciprocal of each other is 1 and cosec square and sec square converted into cot square and tan square. As we know, cosec square A minus cot square A is equals to 1. That's why cosec square A is equals to 1 plus cot square A. So that instead of cosec square we have to write 1 plus cot square A. Same way, instead of sec square, we know sec square A minus tan square A is equals to 1. That's why sec square A is equals to 1 plus tan square A. 1 plus tan square A. Done. Now 1 as it is, 2 ones are 2, plus 2 ones are 2, plus 1 plus arrange it by as we required, plus tan square A plus cot square A. 2 1 plus 2 3 4 5 6 7 7 plus tan square A plus cot square A is our required right hand side. Therefore, left hand side is equals to right hand side. Hence, our left hand side is sin A plus cosec A whole square plus cos A plus sec A whole square is equals to 7 plus tan square A plus cot square A is proved. Hence, up to the 8th number completed. Now we discuss remaining 2, 9 and 10. Let's see the next 9th number. See the question from question number 5, exercise 8.4, 9th number on page number 194. Cosec A minus sin A into next bracket sec A minus cos A is equals to 1 upon tan A plus cot A. First of all, write the left hand side. LHS is equals to cosec A minus sin A into next bracket sec A minus cos A. We need to prove in right hand side 1 upon tan A plus cot A. First of all, we convert this trigonometry ratio in form of sin and cos is equals to, instead of cosec A, which is 1 upon sin A, minus sin A as it is, instead of sec A is 1 upon cos A minus cos A is equals to, now take the LCM in both the brackets, sin A 1 minus sin multiply sin, which is sin square A, bracket is over, 1 minus cos square A upon cos A. Now as we know the identity, sin square plus cos square is equals to 1. Sin square A plus cos square A is equals to 1. That's why 1 minus sin square A is equals to cos square A, and 1 minus cos square A is equals to sin square A. Substitute cos square A instead of 1 minus sin square A upon sin A, and instead of 1 minus cos square A, sin square A upon cos A. Now 1 time cos cot, 1 time sin cot, remaining cos A into sin A. If we have to take right hand side from the left hand side, we required 1 upon tan A plus cot A, so that it is numerator, nothing in denominator, then it is 1. Write it as a 1 upon cos A into sin A. Now instead of this 1, write identity sin square A plus cos square A upon cos A sin A. Now substitute cos A into sin A in both the Denominator of sine square and cos square is equals to 1 upon sine square A upon cos A into sine A plus cos square A upon cos A into sine A. Now one time sine cut, one time cos cut, remaining 1 upon sine A upon cos A plus cos A upon sine A is equals to 1 upon sine upon cos is equals to tan A, cos upon sine is equals to cot A, but it is our right hand side. Therefore, left hand side is equals to right hand side. Hence, our left hand side is cosec A minus sine A into bracket sec A minus cos A is equals to 1 upon tan A plus cot A is proved. Okay. Ninth number is also solved by using left hand side and right hand side separately, or left hand side is equals to left hand side is another way cosec A minus sine A into bracket sec A minus cos A. Up to this term, methods are same. 1 upon sine A minus sine A, 1 upon cos A minus cos A, 1 minus sine square A upon sine A by taking LCM, 1 minus cos square upon cos A. But 1 minus sine square is equals to cos square, same as previous, upon sine A into 1 minus cos square, which is sine square A upon cos A. Now cos cut, one time sine cut, remaining cos A into sine A is our result number 1. Now use the right hand side and solve it separately. RHS is equals to 1 upon, our right hand side is equals to 1 upon tan A plus cot A, 1 upon tan A plus cot A, 1 upon tan A is equals to sin A upon cos A plus cos A upon sin A. Now take the LCM in denominator. Our LCM is cos A into sin A. Sin means square of sin plus cos into cos, square of cos. Denominator go to the numerator is equals to cos A into sin A upon identity sin square plus cos square is equals to 1 is equals to cos A into sin A, which is our result number 2. From 1 and 2, what happened? From 1 and 2, left hand side is equals to right hand side. Therefore, cosec A minus sin A into next bracket sec A minus cos A is equals to 1 upon tan A plus cot A is proved. Okay, is the second method to solve separately left hand side and right hand side. See the last 10th number. There are 3 terms, not only left hand side and right hand side. 1 plus tan square A upon 1 plus cot square A is equals to 1 minus tan A upon 1 minus cot A whole square is equals to tan square A. We need to separately solve first term and we get third as a 10 square and second, and the answer is also 10 square. The first is 1 plus 10 square A upon 1 plus cot square A. Convert cot into 10. As we know, cot is equals to, cot A is equals to 1 upon 10A. That's why cot square A is equals to 1 upon 10 square A is equals to 1 plus 10 square A upon 1 plus 1 upon 10 square A is equals to 1 plus 10 square A upon 10 multiply with 1 means 10 square multiply with 1, 10 square A plus 1 upon 10 square A. Now denominator's denominator go to the numerator and we get 10 square A into bracket 1 plus 10 square A upon 10 square A plus 1. Both brackets are equal, then cut it, we get only 10 square A, which is our result number 1. It is third equals to the third one. We require 10 square. Yes, it is a 10 square. Now the second one is 1 minus 10A upon 1 minus cot A whole square. Convert cot into 10. 1 minus 10A upon 1 minus, instead of cot is 1 upon 10A whole square is equals to, take the LCM in denominator, 1 minus 10A as it is upon 10A multiply 1 with 10A minus 1 upon 10A whole square. Now denominator's denominator go to the numerator is equals to 10A into bracket 1 minus 10A upon 10A minus 1 and square of whole bracket is also there. Now give the square of these three terms and we get 10 square A 1 minus 10A square upon 10A minus 1 square. As we know, 10A minus 1 square, taking minus as a common, write as 1 minus 10A. This bracket only, if we multiply minus with bracket, we get 10A minus 1 and square. If we have to give square to both one, square of minus which is plus and 1 minus 10A whole square. There is no difference between 1 minus 10A whole square and 10A minus 1 whole square. So that 10 square A into bracket 1 minus 10A square upon 1 minus 10A whole square. Both brackets are equal, cut it and we get only 10 square A. It is our result number 2. What happened? Result number 1 and result number 2 gives us third 10 square A. Therefore, from 1 and 2, first is 1 plus 10 square A upon 1 plus cot square A is equals to 1 minus 10A upon 1 minus cot A whole square is equals to 10 square A is proved. Okay. Hence here the chapter number 8 Introduction to trigonometry from the textbook completed. Now whenever we meet in next session, we discuss some extra sum regarding the introduction to trigonometry.